Hey everybody. Today we're talking about the rule of complements. So first of all, a definition. The complement of an event E is just the event that E does not occur. And we represent that with E prime. So very simple Venn diagram here. The circle inside of that is the event E. The big rectangle is the sample space. And so the part in the sample space but not the event is E prime. So that's the less shaded part of the rectangle. Together, E and its complement make up the entire sample space. Two events are said to be complementary if they're disjoint and together make up the entire sample space. So you need both those things. A intersect B has to be the empty set. That just says there are no outcomes that are in both A and B. And A union B has to be the sample space. And that just says that every outcome in the sample space is in either A or B or both. The rule of complements says that you can compute the probability of a complement by taking the probability of the event and subtracting it from 1. An example, here's a chart showing the number of TVs in 65 different homes. And I'd like to know what the probability is that a house has at least one TV. So we could do this just by adding up all the individual probabilities for 1 TV, 2 TVs, and so on. But the rule of complements is going to be an easier way to do this problem, because the event that we're interested in, that the home has at least one TV, is complementary to a simple event that the home has no TVs. So we do 1 minus the probability that the home has no TVs, 1 minus 5 and 65, which I got directly from that plot a second ago, from the last slide, which is 60 over 65, 12/13. One more example. Two fair 6-sided dice are rolled. What's the probability that their sum is at least 4? So this is a good place to pause the video, give it a try before watching my solution. So again, we're going to use the rule of complements. The probability that the sum is at least 4 is 1 minus the probability that the sum is at most 3, because those two events in those parentheses are complementary to one another. All we have to do is compute the probability that the sum is at most 3. And that can happen with the sum being 2, and it can happen with the sum being 3. There's exactly one way to get a sum of 2 when you roll 2 6-sided dice. That's when you get both ones. There are 2 ways of getting a sum of 3. You roll a 1 and a 2, or a 2 and a 1. 36 outcomes total. So I'm doing 1 minus 3 out of 36, simplifying the fraction, and getting 11/12.